In order to verify the inverse square law, you must plot a graph. You must also take into account the physical limits of your apparatus. Your source will be encased inside a container to establish a minimum distance from contact to source. Flesh is affected by ionizing radiation. It can be burnt if exposed to enough radiation, but this danger can be expedited if your flesh is kept far away enough from the radiation source. If you are handling radiation sources, you should never come into physical contact with them. Even when the source is enclosed within the container, you should never handle the container unless you handle them with tongs to maximize the distance from source to flesh. The container is also made of a material which can provide a measure of shielding from the radiation, although for gamma radiation, distance is your best protection. The distance from edge of source container to the edge of your detector is called x. In order to determine the value of k from the inverse square relationship discussed in a previous podcast, you need to measure the adjusted rate of gamma rays detected against the distance from the radiation source. The adjusted rate of gamma detection is the value you record during your experiment, minus the background rate of radiation, which you measure before doing your experiment. To measure the background rate of radiation, you simply leave your detector turned on, but away from any source of radiation, for a few minutes before the experiment starts. Alternatively, you can use a secondary radiation detector somewhere else in the room to measure the background rate during your experiment. This background radiation comes from all sorts of sources and is nothing to be alarmed about. The decay of radioactive nuclei is a completely natural process. The presence of helium gas on Earth is due to the capture of radioactive alpha particles inside rocks, demonstrating the fact that radiation has been around since before recorded time. The majority of background radiation comes from space in the form of cosmic radiation, but other notable sources are carbon-14 in food and drink and medical physical uses. The amount of radiation in the background from nuclear disasters and explosions is very small. Having adjusted for the background rate, you can record radiation rate against distance from edge of source. Now, calculate the inverse square of a distance and plot this inverse square against the radiation rate. This should give a straight line graph with a negative y-intercept. This negative y-intercept will be the magnitude of the distance from edge of source container and the edge of detector to source and detector respectively. If you add this value to the distance from edge to edge, you'll get the total distance from source to detector. The graph of this will also intercept the y-axis at 0. Using the equation for a straight line, y equals mx plus c, where x is the gradient and c is the y-intercept, and comparing to the graph you've just created, you can see that the gradient is the constant k. Y is the radiation level, x is the inverse square of the distance, c is 0, and m is k.